it's my pleasure to introduce David Quartarolo. David is a seasoned information security professional with over a decade of industry experience. He's passionate about architecting secure infrastructure for organizations with a solid background in software development and cybersecurity. David's expertise paved the way for the creation of the Smudge passive OS identification tool. David is a veteran of the United States Submarine Force. His interest is in the Linux operating system, started beneath the waves. After his military service, David has been involved in the technology sector, where he's contributed to enhancing the security and operation of medium to large size enterprises. He is a graduate of Wilmington University. And while he has noted here that he's a 3-time speaker of Secure Delaware, I also wanted to add that I recall pre-COVID, he was also one of the people walking across the stage as a Cyber Fast Track winner. Yes.
Yes.
So he's currently working as the infrastructure security engineer at Dash Financial Technologies. He spends his time off with his wife Heather and their son, the Chaos Monkey. Without further ado, David, take it away.
Thanks so much, Heather. So I like to start off all these things with kind of explaining why I'm talking about this subject and who I'm talking to. So last year, when I was speaking about vulnerability management, this entire room right here was filled with college students hearing me talk about enterprise vulnerability management, and I had a lot of just like stunned looks on what are you talking about? Why are you talking to me about this stuff? So I overcorrected, and I'm talking about home labs now. So I feel like I don't see as many college students as I expected. So I apologize if some of this is a little bit kind of on the introductory side. So I want to kind of start off with a non sequitur about how I got introduced to home labs. After I got out of the military, I was consulting at a company, and I wanted to start in network engineering. And I was lucky enough to have befriended another engineer at the company who was looking to make the same move. And our senior network engineer, on his day off, took us both by the hand and like walked us around home lab equipment, connecting up switches and routers, and basically just explaining things to us and physically connecting devices together. And it was my first real exposure to playing with hardware outside of like a company. We've all had computers and built computers growing up, but I didn't really have too much enterprise gear. So Freddie Chambers, he's a senior security engineer now. He worked for the NFL and Major League Baseball. Super smart guy, and he just spent his day off with some random consultant from the company. So I try to mimic that and try to bring as many people as possible. When people ask me for resources, or when people ask me for help, or how did you get into this, I try to pay it forward. So if any of you are more on the senior level at your companies, or people that are getting into this space, please pass this information forward. These slides are online. I linked to a GitHub repo that I just started, and I'm starting to add stuff to later on in the presentation. So please feel free to pass this stuff along. All right, so Heather gave me a great introduction. I don't want to harp too much on that stuff. My LinkedIn's really impressive. My mom, she loves me. She's so proud of all the things I've done. You may know me from, I have an association with Active Countermeasures, or in the Black Hills Information Security family. They're most of my public exposure. I created an open source project for them called Smudge. I also talk way too much about Ansible on their YouTube channel. As I mentioned to some colleagues earlier, I'm the guy that's currently fighting with SolarWinds on LinkedIn about some of their old software. So that's been fun for me, I guess, for the last couple weeks. So that's who I am. But instead of like listing a large number of accomplishments and stuff, I want all of you to understand I'm talking about this because I've been playing with enterprise equipment at my home for the last 10 years. I'm married with a kid, so when I talk about like things like the partner acceptance factor and like not inconveniencing the people that you live with. I'm not just saying it because I'm some, weird guy that lives in a basement. Like, I have a family, they depend on internet access. This is something that we all know that when our kids don't have access to Netflix or YouTube, like, things are bad. So let's not do that because of our career progressions. It makes all of our lives a little bit easier. Okay, so one of the things when we start going to what is a lab, what isn't a lab, the big thing that I want to kind of talk about is this is mostly for professional reasons, right? We're all either trying to move our current level of knowledge forward, or we're trying to do, we're doing something for work. So I do tons of proof of concepts, so testing software out inside an architecture that might not be, might not have dev environment at work. So I'll do it in my home lab and get great results. But it's really important that when I'm talking about this stuff, I'm talking about isolating it from the internet, right? It has access to the internet, but the internet does not have access to it. I could probably speak for hours and hours about how to securely, provide access to your infrastructure from the internet. Cloudflare has their Tunnels product now that's free for home use, and there's tons of different proxies and firewalls that you can use. But I promise you don't need that unless you have a use case for it, right? Even if you wanted to give somebody else access to it, you want to be focusing on the work that you're doing, learning, or whatever you're working on, and you don't want to be actively fighting fires. Like, it'd be really silly to be like, well, today, after work, I'm fighting a casualty in my home environment. You're just like hacked while you're off the clock. It's something you want to try to avoid. But when we're talking about home labs, I'm specifically talking about not connecting stuff for access from the internet. Do we have any students here? Do we have some hand raising? Students, awesome. Please, I am a very informal person. There's a lot of great speakers I've listened to so far, but you don't have to wait till the end to ask me questions. I'm going over a lot of material that should be like way more than an hour. So answering questions is my main kind of purpose of being here. So if there's something that you have a question about or something specific you want me to cover, please stop me. And I'm also not really talking about hardware acquisition. So I'm going to talk about like the types of labs and the types of things we can do, but I'm not going to go into the specifics for hardware. There are so many different resources online, especially Reddit has a whole bunch of threads about acquiring hardware, getting stuff from work after it's decommissioned. eBay has like just a ton of stuff. But you need to realize that home labbing is kind of, it's not a jigsaw puzzle where you don't just get a box of pieces and you put the components together. It's not Lego, right? You have to figure out what your kind of vision is, what your end goals are, and then you have to figure it out from there. So me trying to tell a group this large about like, oh, you should buy this server, it would just be very ingenuine. Just kind of noting on that stuff. All right. So I had to put this slide in here because it always tickles me that I get to say this. How many people here are scientists? Who remembers like, oh yeah, everybody raise their hand. Everybody please raise your hand right now. Yes. So whenever you have the ability to just take the scientific method and apply it, that's the definition of being a scientist, right? The whole concept of like a 6-year-old at like, a Bill Nye-esque thing where they're like, oh, this leaf is, chloroform is, currently flowing through this. And it's ridiculous how those kids can make all these great observations about the world around us with the scientific method. And we don't realize that we need to apply it to everything that we do. So the big thing here is when we're in a chemistry lab, right, you think of doing science. Even though you're not doing anything new, you're not doing research, right? Most of the time when you're a student, you're just following a procedure. Same thing goes for physics labs. When you're in your home lab, a lot of time we're just following procedures that we're kind of looking up online. We're building infrastructure, we're securing infrastructure, we might be doing some red teaming work. There's a lot of stuff, but we're doing something and then we're looking at a result, right? So if we apply the rest of the scientific method, we're actually doing a lot more science than we are, engineering. And then also, this is a great way for me to put, if you're gonna do a lot of home lab work, start a journal, right? It doesn't have to be like a physical journal. It could be like a notepad with a whole bunch of running notes. But your experience and being able to look back on it and be like, oh, last year I was working on this project, and a year later, look at all the crazy stuff I'm doing now. It's so powerful to just be able to look back on that. But also, I can't remember like the commands that I ran like last night when I was working on stuff. So your history can only go back so far in the terminal. So having a good idea of versions of software that you're running and what you were running it on and all that stuff, it's really powerful. So when you go run into scenarios where you're troubleshooting things, you have specifics. I can't get this to work with that. Well, what is this? What's your problem? What are the error messages? What's your output look like? So having a journal is like really powerful. I try not to stray too much away from technology, because if I'll just start writing, guess what happened today? The kid got stuck in a tree or whatever happened, and then I'll just completely forget about what the actual lab work. But if you write down what you were working on, you'll have like a really great way of tracking all your progress. Okay, so this is the what is a home lab. You have to be, you have to pick what your whole outcome is, right? Do you want to get a job in what, dealing with what? Do you want to just get better at something? Do you want to get a certification? What's your actual end goal? And then build the lab for that purpose. It is not really that smart to build like an entire enterprise network out of Raspberry Pis. You can't really emulate all the things that you're going to have, but certainly that's like single board computers are great for doing like research with IoT, or just figuring out how many vulnerabilities Raspberry Pis have. Whatever your use case is, it's really great to have a purpose-built lab. Now, we can go all over the map with like wireless and radio technologies. Like security is a really big field. I get it. I'm not telling you guys to be like, okay, and then, and this weirdo at the security conference, he's just like, well, we're going to do physical penetration now, and I have to have like, lock picks in my gear. No, I'm not saying that. Just know what you're going to build. This presentation is about enterprise technologies. We're going to stay around mostly enterprise stuff. But there are a lot of different types of labs. So don't be like, take everything I say, oh, I have to do this, I have to do that. This is mostly for the enterprise stuff, but a lot of this stuff will apply all over the map. Okay, so how many people have like gone on YouTube and watched everybody talking about like setting up servers and stuff? How many let's see some hands. I don't know. It's weird, right? It's like really weird that there's like people like, I don't know if they're trying to sell me something or what's going on, but like, why are you setting up like LEDs like behind your, like you're backlighting your server like I'm gonna have a drink now, like it's very weird. We want to get this stuff to work. It's great. We're gonna talk a little bit about like storage and stuff, but nobody's gonna like look down on you if you don't have like a pro-sized rack and you're using a bunch of old computers or like a gaming PC to run a bunch of VMs. Like you don't have to like spend thousands of dollars on lab equipment to get a lot of hands-on experience. Like the main goal is to get hands-on experience with absolutely no downside of it, right? How many people have ever brought a production service or system down? Anybody ever? Oh, okay. That's what happens. It's a very valuable lesson to have. You understand that kind of recovery. You understand how to deal with stress. But you're not going to get that experience if you can't get a job. And it's hard to get a job unless you have experience. And then you get into this like terrible cycle of like, how do I actually get employed? A home lab is a great way of doing that. So there's no reason why it has to be like, you don't have to be scouring eBay for like a rack that's being thrown out and like, be like, oh, now I need to figure out how to program NeoPixels so I can backlight this for the next YouTube video. Like it gets kind of weird. Also, I kind of want to shout out, there's this idea that home labs and home servers are the same thing. Like, and you'll see a lot of people do this. We are talking about doing IT work. We are not talking about like pirating every Disney movie ever and serving it to your family. So like, if you want to, if you want to do that, just not in the home lab. That's the home server stuff. I'll do that talk next time. So just, there's a bit of a difference. Home labs are totally meant to be turned off at the end of the day, not something we have to get uptime so, 5-year-old doesn't cry because, he can't watch Mulan or whatever. Yeah, and then we talked about crypto mining at the beginning of this. No crypto mining, right? This presentation is free of crypto mining and AI, and we're going to keep it that way. Okay, so there are so many different ways we can kind of utilize our lab space. But the most important thing is doing stuff you just couldn't do in a production environment. So I mentioned at the beginning of my career, I was a network engineer. And when you run debug commands on Cisco gear, it adds like a ton of CPU utilization, and production networks that can be like really bad. It can just spam a whole bunch of stuff. But as a network engineer, I kind of wanted to see what those messages are. I kind of wanted to learn how to troubleshoot those issues. So I put a whole bunch of gear in my home lab, and I was able to do all that stuff at home. I also like breaking stuff. How many people like breaking stuff, right? You can't do that at work, or well, I guess you can, or it won't be working there very long. But I love being able to just, hey, we're not doing this correctly. Let's attack it. Let's see if we can find a way to exploit this thing. It's a great way of kind of identifying risk. Like all the time, if you were at my last talk on vulnerability management, I talk a lot about looking for exploits. Like, yeah, it's great. We understand this isn't like super secure, but what's the actual risk here? Well, it's great if you could just take that risk into your home lab. Can I exploit it, right? What am I seeing on the server side? What's going on there? Bring that result back to work. Tell your coworkers about it. Show them. I've dragged my boss into my home lab more than once, virtually, not physically. That'd be weird. But it's great to just be able to show, hey, this is what happens when we're not doing the right thing. And just having that ability to have a place to do all that stuff. Make mistakes without any consequences, show people how to do stuff, teach people, not have to set everything up. We're going to talk about certain operating systems. I'm not going to talk about Windows very much. But every single time I have to test a Windows server, it will only be in a lab environment because Windows scares me. And thinking about trying to set that thing up correctly when I have to click on things instead of just type things like a normal person scares me. So I always forget all the settings of the thing, even with checklists. So knowing that I could just turn that off when I'm done is like a huge benefit to me. Okay. So I started talking about this a little bit. Do I have like a pointer on this? I guess not really. Oh, I do. All right. So the whole idea of identifying your goals, this is a very genuine thing that like you have to kind of know about. I am mostly a blue teamer. I started off my career more on the red side. But knowing how to set up infrastructure securely and then test it out as much as possible without really worrying about it going down, it's awesome. But you don't do that when you're like trying to study for a certification, right? You're going through the list of things for that certification to understand, oh, this is how I'm going to fulfill my goals, right? This is how I'm going to learn about DLP, or this is how I'm going to understand like Linux better. So after you figure out what you want to do, then you understand your constraints. We are all normal people. We can't just like be like, okay, now I have 10 grand to go build a home lab out. That's not like how any of this is supposed to work. Some of us don't have enough room. You know, I definitely, when I got married, I was still in an apartment. You might not have space for a physical lab. You might have to go to something cloud-based or something in a small form factor, right? Understanding that stuff before it has like real impact on your life, it's critical that we take that step. You all have stuff. So there's a lot of technologists in this room. So like I know there's at least one technology hoarder who, you don't have to identify yourself. I'm not asking you to raise your hand there, but there's at least one of you here that has a whole bunch of extra stuff that you probably don't use anymore. We all have that extra laptop that we're not using, that extra old PC that still probably can be used for something, just in case, right? Oh man, that hits hard, man. Oh.
How are you going to test Linux Mint?
Oh man, I needed a 32-bit system. It's how it happens. So we all have that extra stuff that we have. But when I say inventory your assets, it's not just the stuff you physically have, right? We all have a network of people, right? We're all here in one space. We're networking right now, right? As a community, there is stuff that I have that you guys probably don't have. That you guys probably don't want. But there's stuff, if you ask the right people, if you ask people further along in their career, they might have an older server that they're not using anymore. They might have some network gear. I've passed along a ton of gear to people that I've worked with that were working on the stuff I was working on that I'm not working on anymore, right? Contact people that you know. The company that you work for might be getting rid of something. The school, the church that you're going to, they might have stuff that they're getting rid of. Ask first, right? Before spending any money, always kind of inventory that stuff. You don't need, a brand new, server to run all this stuff on. Again, stay away from the YouTubes where it's just like some random kid. They're like, oh, and I called the company up and they just gave me this like 80 grand worth of server equipment. And that's why you shouldn't watch Linus Tech Tips. It's just like a terrible like situation to be in, and there's this, our kids are just looking at these YouTubers and they're just like, they have everything that they kind of want and don't even need. We don't need all that stuff to fulfill, basic requirements of having a lab. Architecture, we're going to talk more about that later, but basically it's just the resources that you need, the virtual resources that you need in that lab to kind of fulfill all of the stuff. And then lastly, planning and executing. After you have all that information, planning and executing is like really great to do. All right, so this is a kind of an example, getting your first job, right? Small apartment, not a ton of money, busy lifestyle, right? This should help us get the career. It shouldn't you shouldn't have to get a loan to get this stuff. You're not going to be able to be like, well, if I spend $35,000 worth of server equipment, I'm going to get $35,000 more on a salary. That's not how it works. It just doesn't add up that way. So in this scenario, old gaming PC, there's so many people with old gaming PCs. Like all of a sudden, it can't run some game and then they just buy a new PC. Ask your cousins. It's just strange, the stuff that people have. I imagine that if it plays some of the newer first-person shooters, that I'm sure it will run, probably more VMs than you'll ever use in your entire career. Design and architecture, so PC plus laptop, firewall, IDS, and web application. That's for virtual machines, right? So how much memory and CPU do you need for a virtual machine? Well, in Linux, it's not that much, right? You can get a lot, some of the more bare bones distributions, 2 to 4 gigs of RAM, is more than you need. You're not, remember, it's you, right? Unless you're doing a whole lot of traffic generation, which could be your use case, right? You probably don't need that much memory. And then you could also scale it with a lot of the hypervisors that we'll talk about later on. There's also the ability to just bank that RAM where you're only using it. You can configure it to just kind of bust and burst, so you have more resources when you need it. So you really don't need all that much hardware to run 3 or 4 different virtual machines. and then plan your deployment. This is one of those things I mentioned earlier. This is kind of like a choose your own adventure. Who remembers choose your own adventure books? Remember those things? Those things are awesome. But the thing that I remember most about it, it's kind of like you woke up from the dream, or like you got killed by zombies. Like it's never like, it's never like two things that are like really close. It's never kind of like you came in first in the race and then like, or you came in second in the race. It's always like extremes, right? Your deployment is going to be up to you, right? So I might want to do something with containers. You might want to do something with virtual machines. You guys might want to do something with a Windows virtual machine, and I won't. So it really depends on what your kind of end goals are. And then lastly, you put get it done. This takes an incredible amount of discipline, right? You are giving up your free time. Nobody's going to pay you to do home lab work, right? So this is your free time that you're not spending with your family, that you're not getting paid for. This is to improve your professional skills, right? So if you think about this and plan everything tactically, you don't have to spend weekends on this. You can spend an hour here or there. And this might make me seem like a terrible person, but I'll share it anyway. So my wife will sit on the easy chair in my office, my son will sit at his desk in my office, and the three of us will exist in my office, and I can spend time with them while doing stuff like this, right? So it might not be optimal, but COVID trained them pretty well, so.
So you don't have to spend a weekend doing this. You get to spend a weekend.
You get to spend a weekend doing it, exactly. I'm going to add that to my notes. That's pretty great. All right, operating systems. In a lot of these things, I kind of put the bar here where everything above the bar is open source and completely free, and everything kind of below the bar is stuff that you have to either pay for or register for or get like an educational license. These are kind of just suggestions. So I'm far enough in my career where I get paid for officially endorsing products. So these are just suggestions. But things like Ubuntu or CentOS, they are a lot easier to set up, right? They're kind of pre-configured with a lot of defaults. Debian, like you have to do everything from scratch, right? It's not configured, like SSH access isn't like configured by default. You have to do everything from scratch. But you learn a lot more when you're doing something completely from scratch, right? And I also want to note that we're talking about servers. We're not talking about your laptop. So you might see that there's a bunch of Linux distributions that you're probably not seeing up there. Arch, right? That's great. That will teach you a lot about Linux, but on your laptop, not on a server. I heavily recommend that you don't put a front end on these things. No desktop environments. In the real world, desktop environments add a ton of latency. They take up a ton of memory. There's no reason for them. They add an extra level of vulnerabilities. So many vulnerabilities. Keep stuff that doesn't need to be on these servers off these servers. Just add what needs to be added. But again, suggestion, it's your home lab. You get to choose your own adventure. That's just my recommendation. Don't get killed by the mummy. The bottom stuff, Windows servers. You can get free licenses now. Just remember, it's going to always remind you that you have to install a license, right? There's certain things that might be very hard to get, right? If you want to do something like Windows Hypervisor, Hyper-V, very easy to get that. Very difficult to start without like the pro licenses. It's just not the same level of hand-holding as with the licenses. Oracle, man. Oracle, good luck. It is so difficult to get an educational license for that. There's a waiting list. It's just not a good situation. However, it's really just rebadged CentOS. It's just kind of configured in a way that they can support it properly. So I wouldn't worry too much about that unless you're going for an Oracle certification, right? If you're going for an Oracle certification, that certification will probably provide you a path forward for those licenses. And then Red Hat Enterprise License. I'm a Red Hat developer. If anybody can be a Red Hat developer, who has an email address? Everybody have an email address? You can be a Red Hat developer too. You go on their website and you say, I want to be a Red Hat developer, and that gives you 3 licenses, right? That means you can install 3 different Red Hat servers. If you don't install a license on a Red Hat server, you can't get any updates whatsoever. It is not a great time. So that means if you want to install a package, you have to manually move it over to that server. It's not a great experience. I wouldn't recommend it. All right, hypervisors. I love Proxmox. Proxmox is just basically a little bit of a facelift over the Linux virtual kernel, the KVM. It is awesome. It is free. You can pay for support if you want. If you're a professional organization, I wouldn't. It gives you kind of the best of both worlds. OpenVZ, Linux KVM, Zen Project, these are all basically the same. These are all free, but they're not supported. So that means if you have an issue, you have to go on a forum and ask somebody. You can't just call for help. VMware, ESXi is free, but they don't give you the newest version. They don't give you vSphere, right? A vSphere license is $300 if you go through the educational license. It's not fully supported with all network stuff. So is it important? If you're a VMware shop and you want to do things how they're doing it in work and you're looking specifically for vulnerabilities on that hypervisor, yes, I would say that's important. But if you're just trying to get virtual machines built, probably not all that important, right? So you kind of have to figure, take these things into account for. Proxmox can get installed on a Raspberry Pi. It's not a great experience, but it works. When you move up to something like VMware, there are minimum requirements that it enforces. So you almost need something that's enterprise grade to run it on. All right. Firewalls, this is more of the security stuff. So I talked a lot about some just general lab stuff. The general lab.
Sorry, can I back you up just a second?
Absolutely.
You just went over VM machines.
Yeah.
Is there a way to get Windows, you talked about Windows Server and stuff, educational licenses, how about Windows in general? And
Okay.
Or can you elaborate a little bit more?
Absolutely. So,
I haven't done
yeah, absolutely. So, so a hypervisor can run virtual machines. So any hypervisor can run, the virtual machines that they support. It's more about the build than it is the operating system. So if you wanted to run Windows on Proxmox or Windows on Zen or Windows on a bare Linux KVM, you can run it. It's pretty easy to do it. So if you are, if your lab is going to have the mummy kill you at the end of it, I think that's the analogy I'm using for Windows at this point. I'm sorry, I'm not bitter at all about it. But thank you so much for asking the question. I really appreciate it. You can definitely, so once you have the hypervisor up and running, you can just install the VM like it's a normal VM, right? So you can just import that Windows ISO. I highly recommend you get the Windows ISOs directly from Microsoft. Do not ISOs are so they're all over the place, but if you get it off a torrent site, you are going to experience malware. So get the ISOs for Windows off the Microsoft site. Try to get the ISOs for any of these other projects off the official sites. ISOs are just so easy to just embed malware in because they're basically zipped files. They're just compressed files. So try to get those files directly from the source. It's all free. For Windows, okay. So VMware, you have to go on. They have an educational organization. I think it's called it's VMware.edu or something like that. You have to spend $300, and they'll give you the vSphere license for that. ESXi, however, which is no front end whatsoever, that you can get directly on the VMware website for free. If you don't want to virtualize at the server level, if you want to build servers on your machine, there's other products for that. VMware has the desktop one. I'm going to forget the name of it. Somebody knows? Oh yeah, yeah. VirtualBox is the open source one. VMware Player is Player. Yeah.
Player doesn't allow you to install though. Last I checked.
Oh, it doesn't? Oh, when did that change? Everything's terrible.
I could be wrong, but I don't remember having the ability to do that without having the full.
So VirtualBox is the open source version of that, and I think it works better on Windows anyway. So I would go that route. But yeah, if you don't want to do like the full-blown running VMs on a server, it's a better route of going. The Windows stuff, you can run that stuff license-free. You don't have to get a license from anywhere. It won't let you have certain capabilities, but as far as like getting it installed, you can get those licenses will just allow you to install the servers. You might have to provide an email address, but you don't need to get educational licenses for Microsoft builds. Yeah, you're gonna run into, like if you're trying to do something cool, it's gonna tell you, no, you don't have a license installed, but for the most part, just to get it up and running and like testing some stuff out on, you're completely fine without it. All right, suggested firewalls. So this is where you have to figure out what your tolerance for pain is, right? Because some of these are a lot easier to use than others, right? So the standard's always going to be things like the stuff on the bottom, the really expensive stuff on the bottom. That's like if you wanted to get industry level experience with a firewall, that's the stuff that you have to like dig out of the dumpster. You know, who's getting rid of that old AS500, you know, Cisco firewall. You know, most of this, it's pretty easy to acquire on eBay without like spending a lot of money. But if you wanted to go the open source route, pfSense and OpenSense are both really awesome. The only big thing that I'm just gonna like say out loud is they don't run Linux, they're on FreeBSD, right? So FreeBSD is a little bit of a different animal. So patience and Googling. It's just kind of the end of the day, you just kind of have to be prepared to be a little bit patient there. But the ideas and the concepts of firewalling, those are both great open source projects. You also have UFW, the Unix firewall. You know, it's basically an implementation of IP tables. Knowing IP tables rules on an interview is something that I've been literally asked like 40 times throughout my career. It's a question I 100% ask. Everybody uses the same format for firewall rules. So if you just want to like be able to be like, okay, well I'm using this Linux server as my gateway, like I want to put IP tables on it and like figure out how to restrict access to my network, you can go something like as minimum as that, or you can go as something as like complicated as something like OpenSense. But the UI is beautiful on that thing. Like compared to like what we had 10 years ago, like it's a joy to work on that thing. Okay, so this is kind of the meat and potatoes. So this is where the whole choose your own adventure thing like really comes in. Like, what do you want to do, right? Do we want to be a red teamer? Do we want to attack? Those guys are prima donnas. I love all of them. I had 2 red teamers work for me on my last job. Installing a bunch of like vulnerable machines on your network just to like break into, it's awesome. It's like such a great experience. Like 2 in the morning, you know, you're like kicking over lamps and screaming, and the wife, you know, thinks that somebody broke in the house. It's like amazing. It's like the greatest feeling in the world. But there's a lot of different scenarios we can do, right? There's a lot of different security tools that are out there. So I recommend, right, on your security journey, figuring out the companies that you're working for and doing a little bit of OSINT and figuring out what they're running, right? It's not hard to like go on their LinkedIn and their like posted jobs and be like, okay, what are they looking for? Who's applying to these jobs? What do they have on their resume, right? I thought it was a niche product that I heard about it at a security conference last year. And I'm like, wow, that's really cool. I'm gonna play with that. And then I interviewed at a company that was actually using it, and I felt really stupid for not spending more time on it. You have something like Alien Vault, which was bought by AT&T. I didn't think that they existed anymore. They have a huge community behind them, right? There's a ton of people using that product. You have AC Hunter. They just released Disclosure. That was the company that I did some contracting work for. They just released a community version. That's like an open source front end for Zeek logs, where you could do a lot of threat hunting. It's like a threat hunting platform. It's so awesome that you can like spin up an entire threat hunting environment in a couple of hours. And then once you get used to it, maybe a couple of minutes. So having all these tools, there's a lot of stuff. Monitoring, management, we talked a little bit about security events and logs, right? Knowing Grafana. If you know Grafana, like your security people won't hire you. Everybody will want to hire you. Grafana is like one of those things. Building dashboards in Grafana is like hugely needed in our industry right now because the DevOps people will want you, the finance people will want you. Everybody's using Grafana. This crazy Australian guy that I met last year, he built Grafana dashboards for entire fleet of ambulances in like Perth, where like they had Grafana dashboards to like tell them when to change the oil and like when brake lights went out. Like Grafana does a ton of stuff and the visualizations are like next level and it's completely free. So there's so many tools that you can try out and figure out in the lab. That's why labs are so powerful. You have all these options to do all this crazy stuff. And most of these tools are free and open source, so it's pretty awesome. Okay, so we talked a little bit threat hunting. How many people know what threat hunting is? Anybody not know what threat hunting is? Okay, so I'll just talk a little bit about threat hunting. The idea of going into an environment that you've never been in before and looking for something that could possibly have already been compromised is threat hunting. So it could be your email, it could be the server, it could be the network. Servers are really good at hiding compromises. Networks are not, right? If you're doing threat hunting on the network side, something like Zeek and AC Hunter, something really awesome that you can do. Zeek and Suricata or Snort, who remembers Snort, right? All that stuff, really important. Threat hunting is going to be the next biggest thing because you're not doing things like, attacking somebody or looking for vulnerabilities. This is, oh crap, we already have the Russians in our environment, right? This is something really important that we have to do. Identifying issues, holes in our security, that's what threat hunting does on a regular basis. Pen testing, I don't think I have to talk too much about that stuff. I do want to shout out, other than having a different physical hardware build, one of the big differences between a dev environment, a home lab, and a production environment is traffic, right? And users, right? We're not in IT because we don't want people to use our networks, right? We want lots of people on the networks. We're empowering business. It's very important. That's what we're here for. We're not here to build pretty architectures. I like pretty architectures, but that's not what we're here for. Having traffic in your environment is tricky because you have to synthetically generate that traffic or allow people that are not known to be in your architecture. So that's it's kind of a tightrope walk, but it's something that's worth kind of figuring out if that's part of your home lab strategy. So it's pretty cool stuff. Malware development. Do we have any developers in the house? Any developers? Developer? I just came from a company with a large malware remediation team, and I built many solutions to kind of keep malware in its box. It is not fun. Building environments that are secure enough to house malware, it's very, very difficult to do. So if you want to do something like malware development, I would segregate that network as well as you can and then only develop on one laptop, like a physical machine. Developers are really good at sharing resources. And by sharing resources, I mean stealing lines of code, because we all do it. You go on GitHub and you find something that's awesome and then you make it more awesome or less awesome, depending on how good of a developer you are. And most of the malware issues that I see are developers grabbing malware and then infecting themselves on accident, right? It just happens. We had a malware team. The QA team decided to set up a QA box. And so they're like, okay, well, the malware is running. Let's make sure it's up. And then they visited the site with their web browser. And then I fired them. And it was terrible. I mean, the company's better off now. But just be really careful if you're, 5 minutes. Okay. So I'm just going to, all right. Tips, separate home network from lab. Kids need Netflix and YouTube and stuff. My wife works from home. I'm sure a lot of your partners probably work from home. Don't take down their network. It's bad. Separate and segregate, right? It's very, very important to do that. Strategy for the noise and the heat. Physical enterprise grade boxes. They create a lot of heat and they're really loud. So if you don't have a basement, figure out a strategy for dealing with that. It's October. That means it's not just Cybersecurity Awareness Month, it's also Fire Prevention Month. Don't set something on fire. So have a strategy. My strategy is a well-ventilated closet with a smoke detector and heat sensors. Do what's best for you. Most of the time, if your solution isn't big enough, it won't need it. If you need to push everything to the cloud, it might be a solution, but it is way better to spend extra money in the cloud than it is to have your wife yell at you all week. Mentioned a lab notebook, very important. Set a budget for money and time. We talked about money. Time's more important. Chaos Monkey needs a dad. I spend a lot of time with him. It's more important that you see your kids growing up than it is to spend time in a home lab. Small goals are better than big ones. Super important. When we sit down for an hour, don't try to be like, okay, and now we're going to set everything else up. Get this working. Get that working. Small projects, VMware build, set up networking, troubleshoot networking, verify networking. Small goals is going to get you a lot further than trying to do everything all at once. If you try to do everything all at once, you're going to fail every single time. So I have a GitHub resource up here. It's just a README that I have a whole bunch of resources for. Most of the links are the tools that are in this presentation. I promise you I'm not the only game in town. If you go on there and you say, hey, you don't have this or you don't have this, open up an issue and I'll just add it immediately, right? Give me a GitHub pull request if you know what that is. There's a developer, you raised your hand, I'm sorry, sir. Give me a pull request and I'll drop everything that I'm doing and fix it immediately. And then that's my LinkedIn. You can see me fighting with SolarWinds. Keep up with all of my random, the random opinions I have and how we're all, moving along this cybersecurity journey together. I'm real positive, except for that one thing. So friend me on LinkedIn or connect with me or whatever, and ask me questions later on, or tell me how bad this presentation was, so it'll be better next year, and all that good stuff. So thanks everybody for showing up, and I appreciate everybody's time.